All right, the first part of the problems that we're going to look at today, we're going to start with what I would consider to be a more basic one-step stoichiometry problem, and that's going to be a mole to mole problem. Okay, so this is mole to mole stoichiometry. And hopefully by now you've already watched the video on or been in class for the 3 steps for solving problems successfully in stoichiometry. If not, I suggest you stop right now, go back and watch that one, and then come back to this. So for those 3 basic rules, we're going to start with going from mole to mole. That is step 2. We do not need to look at step 1 or step 3 for this. So I'm going to give you guys a problem, and our equation for today is going to be C2H4 plus 3O2 yields 2 CO2 plus 2 H2O. Okay? The question that we want to answer today, sorry, I'm off the screen there. The question that we want to pay attention to today is going to be this. So here's your big question. How many moles of oxygen, which is O2, will 0.65 moles of carbon dioxide produce or yield? Okay, so the very first thing we have to do with this is figure out, okay, what do we have? What are we looking for? What do we do? So the first thing that I notice in this is the first number that comes to my vision, and that's 0.65. It's a number smaller than 1, and it's a number of moles, okay? That is our given. And then we want to identify, what are we trying to find? So in this case, it's how many moles. That's what we are trying to find. So if we go back to our steps, our 3 basic stoichiometry steps, are we converting from grams to moles? No, we're not. It doesn't say anything about grams. Are we converting from moles of one to moles of another? Yes, we are. Are we converting from moles to grams? No, we're not. So in this case, this right here is the only step that we're going to need. So if we go back to this, then that'll help us figure out exactly what do we need to do in order to solve this particular problem. So get you back on the screen there. So what we have is our given, and we're trying to find here. So let's go ahead and start by writing down our given, and that is 0.65 moles of CO2. Every single time that you start a problem, you need to write down 3 things. Those 3 things are your numerical value, your unit, and your element or compound. Every single time. 1, 2, 3. If you don't have that, it's not complete and it's incorrect in our class. Okay. After that, you need to write down your, what some people call railroad tracks, or your T-chart, whatever you want to call it. This helps you keep organized. Okay. This writing these things down keeps you organized. There is no perfect way to memorize all the steps to do every single problem, because there's so many different variations and options. What you need to do is write down your given. And obviously this is a problem. We need an answer. So the given is not the answer. So that's what we want to get rid of. Whatever you want to get rid of, put over here on the bottom in the trash can. Okay, so that means that we want to get rid of moles of CO2. So we're going to put moles of CO2 down here on the bottom. Okay, now what are we trying to find? We're trying to find how many moles of oxygen there are. So I'm going to put moles of O2 on the top. Now, I need to go back to my steps again. If I'm converting moles of one substance, in this case it's carbon dioxide, to moles of another, oxygen, I need to use the molar ratio. So I need to go back to my original problem, and my molar ratio is the number of moles of each element or compound in my original problem. So how many moles of O2 do I have? I have 2. How many moles of, sorry, I just read that wrong. How many moles of CO2 do I have? Excuse me, that's 2. How many moles of O2 do I have? That's 3. Okay, now you have to plug it in your calculator. 0.65 times 3, because it's on the same level, just like when we used to do triangles, divided by the number that is on the bottom. And that gives you, if you plug it into your calculator, you've got 0.65 times 3, and that gives you 1.95 if you need to go step by step. And then we're going to divide that by 2, and that's going to give us 0.975. Now, we started out with 0.65, that's 2 digits, so we're going to end up with 2 digits, so we need to make this not 975, but this is a 5, so we're going to round up, and it's going to be 0.98 moles of O2. And that is your final answer for that question. Okay, you can do the exact same thing for any question up there. So now I know that 0.98 moles of oxygen right here will help me to produce 0.65 moles of CO2. Okay, so that's the basic for a mole-to-mole stoichiometry question. We could also do the exact same thing for C2H4 or for H2O. You still start with whatever they gave you in the beginning, which is 0.65, and then you use your molar ratio. And the only thing that's tricky maybe that you have to remember, whatever you're getting rid of, put it on the bottom. This is the trash can. Put it down here in the trash and get rid of it. Once you do that, that helps you to cross out those. They cancel, and you're left with what you want to have, which is moles of O2. Okay, we could go on and convert that to grams, but we don't need to. The problem didn't ask that. The problem asked us how many moles of oxygen are compatible with moles of carbon dioxide. Okay,